This formula represents a massive mathematical bridge. It details the global Logos state space and its Adelic ring decomposition. Our goal is to take fractured, isolated prime number data, the local pieces on the right, and stitch them into a continuous global space on the left. This flowchart outlines how we get there using a three-tiered architecture. We start at the micro level, extracting pure spectral data at individual primes. Then we use a structural bridge to smooth out localized singularities, moving up to the macro level where we establish global reciprocity. You cannot simply map a jagged singular local point directly onto a smooth global manifold. You have to translate those local points through a strict step-by-step mathematical pipeline to make the geometry fit perfectly together. These baseline matrices track local data. Left, path B, the Steinberg component. Right, path A, the ramified principal series. Notice their behavior. Steinberg is rigid. Satake parameters lock into an exact ratio. The ramified principal series varies freely, creating a crosstalk block measuring boundary volume. By following these specific, localized matrix features as they are evaluated, continuously deformed, and finally integrated, we assemble a complete, working global function. This table shows exactly how we start evaluating the data. We take abstract Galois inertia subgroups on the left and translate them directly into automorphic parahoric structural idempotents on the right. Applied to the Steinberg representation, the unified trace formula breaks into three matrices: tame projector, wild projector, and monogeny defect. Calculating their traces step by step, the empty spherical core yields 2, minus the wild projector's 1, plus 1, giving an exact local conductor of 1. This trace evaluation extracts the exact local geometric signature required for the global equation to function. Shifting to continuous deformation along the over-convergent eigencurve, our matrix flow develops a problem. An off-diagonal crosstalk block emerges. To handle this, the Jacquet functor filters out the unipotent subspace. The crosstalk zeroes out, cleanly decoupling the matrix into independent one-dimensional torus spaces. By forcing that unipotent element to vanish, highly entangled ramified data is untangled. It stabilizes into pure, traceable eigenvalues. To reach the global sphere, we map our local atolls across a logarithmic boundary singularity, or cusp. We cannot integrate directly across it, so we use the Frobenius scaling law. This pullback equation enforces uniqueness during Coleman integration, yielding the exact monodromy jump. This specific integration technique acts as a mathematical adhesive. It pulls those singular boundary features into a continuous global manifold without breaking the underlying topology. This large formula is the global functional equation. We assemble our derived local components here using the global Mellin transform. It acts as an integral frequency scanner, translating our localized boundary data into a complete analytic complex function. Focus on the central box. The specific local Hecke eigenvalue we tracked from the Steinberg path drops directly in, providing the exact negative sign for the completed epsilon factor. Now look at the right side box. The exact Arden conductor exponent of 1, which we derived earlier using spectral projection, maps directly into the geometric exponent of the integral. Logos field theory successfully constructs a perfectly balanced, symmetric global functional equation built entirely from rigorously isolated local parahoric matrices. To recap the entire pipeline, we start with a raw local matrix shape. We evaluate its structural idempotence to find the trace. We continuously deform it, using the Jacquet functor to diagonalize the crosstalk. Finally, we integrate it across the boundary using the Mellin transform to reach the global lambda equation. Fractured local arithmetic behavior and continuous global geometry are not separate phenomena. They are structurally identical components of a single unified reality.